Hello everyone, in this TRC car tutorial number 48 we will review the bipolar junction transistor invention and how it works using several analogies for the explanation, with a quick remind of the PN junction invented by Russell Hall. Finally, we will compare the bipolar junction transistor and the point contact transistor, and we will do a summary of all the electronic component invention from 1904 to 1951. This slide is just a quick reminder to say that the bipolar junction transistor invented by Shockley is based on the PN junction invented in 1940 by Russell Hall, through several discoveries like impurities were playing a key role in the semiconductor. Then the crystal should be as pure as possible before to be doped with different type P or N doping. The field effect transistor was invented in principle before the point contact transistor, but the technology to build the field effect transistor was not ready. As we saw, the point contact transistor was derived of the point contact diode, and the bipolar transistor was derived from the PN junction. So, to explain the bipolar transistor function, I will start by a PN junction. Again, I will use analogies, replacing electron with higher energy by a stand-up person and the electron with less energy by a sitting person. In the N side, the high energy electrons are represented by several stand-up persons, which are equivalent to the N carrier concentration. On the P side, chairs represent the low energy position available for the electron in the valence band. A person sitting on the chair represents an electron recombined in a hole located in the valence band, which means lower energy. The N minority carrier concentration in the P-type is represented by the stand-up person with high energy, which means in the conduction band. The sitting person found the low energy position in the valence band. Each person needs some time to find a low energy position, so just after the junction we will find more stand-up person, but as soon as we are far away of the junction, we will find only sitting person. Now, we add a second PN junction to build a NPN structure, but if the base width is much longer than the N minority carrier diffusion length, the base collector junction bias in reverse will not see any N minority carrier, means no stand-up person. All the N minority carrier will be recombined in the valence band, represented by sitting person. With the water channel analogy, the fluid representing the electron current in the conduction band is completely transferred or recombined in the electron current in the valence band. Because the base width is much longer than the N minority carrier diffusion length, the bipolar transistor effect does not work. The NPN looks like a NP junction bias indirect, in series with a second PN junction bias in reverse. If we reduce the base width to a distance much lower than the N minority carrier diffusion length, some stand-up person, means free electron in the conduction band, will reach the electric field created by the space charge in the middle of the base collector junction. When the free electron or the stand-up person is in the space charge, an electric field E, represented by the red arrow oriented to the left, produces a force F equal minus QE directed to the right, which means in the collector direction. The consequence is that the NB concentration at the base collector junction will become 0 instead of the dotted line value, because if an electron was there, it will be sent immediately in the collector side. In this case, if we redo the water current analogy, when the diffusion current reaches the abrupt cliff, the height of the water is minimum, which is equivalent to the N minority carrier concentration. Almost the totality of the diffusion current will be in the waterfall. I said almost because a small part of the water will be infiltrated in the permeable soil shown by the dotted line. This water infiltration is the analogy of the base current. The waterfall is the analogy of the collector current. With this analogy, it is obvious that if the base width is minimum, the base current of recombination current or infiltrated water will be minimum too, and so the current gain IC over IB will be maximum. I hope analogies with water channel, waterfall, and stand-up or sitting person replacing the electron will help someone to better understand the bipolar junction transistor component, because even if it is less and less used, we should not forget that it is the one who really started the microelectronic industry revolution that we know today. The point contact transistor symbol looks like a PNP, but in fact it is not. The transistor base is a N-type, and both emitter and collector diffusion in the N base is in metal. The real PNP function is completely different than the point contact transistor with alpha ratio always less than 1. But the best advantage of the bipolar transistor is the fact that we can build two types of transistor, the PNP and NPN, due to both charges type electron and hole, with P and N doping. This allows to do a low side switch with the NPN or high side switch with the PNP with a common emitter topology. We can also do a follower stage with NPN and PNP using the common collector topology. This solution was not working with vacuum tube or point contact transistor. In this last slide, I did a summary of the different electronic component invention. In 1904, the vacuum tube diode was using the thermionic emission. In 1906, the point contact diode was using the solid-state electronic. In 1912, the triode was invented by adding a grid between cathode and anode. With this new component, we were able to do the first amplifier. In 1940, Russell Hall invented the PN junction. In 1947, a second point contact on the point contact diode created the first point contact transistor. With this new component, we were able to do the first amplifier using the solid-state electronic. In 1951, the bipolar junction transistor invented by Shockley was built for the first time. As the point contact transistor was coming from the point contact diode, the bipolar junction transistor was coming from the PN junction. It was working much better than the point contact transistor. It is interesting to see the common point between all those components. For the thermionic emission, the electrons are produced by the cathode at 800 degrees C and accelerated in the vacuum with an electric field to the anode. In the triode, the electron flux is controlled by the grid. In the solid-state electronic, if we are looking the NPN type, the N+ provides electrons in the PN junction, and the narrow base width controls the electron flux as a grid in the triode. As we already said, the NPN has similarity with the triode because they work with a majority electron carrier. But the bipolar junction transistor can also work with holes equivalent to a positive charge by using the PNP structure. I want to thank you for your attention. On my next ERIC tutorial number 49, we will do a summary of all the electronic invention. So see you soon and stay tuned.